Well, according to the guy I bought this TS-830S from, the receiver is dead and the Vox doesn't work. So I'm going to begin looking at this by trying to get the receiver to work. Now I found out the receiver's not dead, it's deaf. Right now I'm running a signal in from a generator here. Right now I'm running a signal at 1.8 megahertz into the antenna jack of the radio, directly into the antenna jack. As you can hear, I'm getting noise but no signal. But now I'm going to increase the amplitude. Let's try 10 microvolts. Still nothing. Let's really hit it some more. Let's try 100 microvolts. I'm starting to hear something. Let's raise the amplitude. Okay, there's no indication yet on the S meter. That's running pretty hot. Let's see, 3 millivolts. Okay, let's run it up some more. There's 10 millivolts. We're starting to get some indication on the S meter. Okay, there's 100 millivolts. And I'm getting about S8 on the S meter. So the receiver isn't dead, it's deaf. So we'll have to find out what the problem is. Actually, I already started looking into it. I started here running a signal in, and then I went to what's called test point 1. Okay, starting at the antenna terminal here, I began by cleaning the relay contacts. Of course, didn't do anything. Following the signal down here, it goes through the attenuator switch, and that seems to affect the signal. So I'm still measuring okay to here, and then we come up to the RF unit, and at test point 1 here I'm getting a fairly strong signal level. Going to the first amplifier here, Q1, this is a dual gate MOSFET. I don't get any signal at that point. And I tried measuring at the wafer switch here on the common terminal here, and I get no signal there. Now I was able to measure on this side of L41, this transformer, I was able to measure signal. It's getting through to this capacitor. So between L4 and the output of L41, I'm losing the signal there. Unfortunately, the RF unit has to be removed from the radio to get access to the bottom of these terminals. I was able to probe using a long probe up to this point, but now we've lost signal. So I have signal up to this test point TP1, but I don't have any signal on the common of this wafer switch. This particular wafer is the input to the tuned circuits on the input, and I get no signal there. So, and this transformer here, this is L41. So the signal is lost between C7. Right, the cap I'm pointing to right here, this is C7. And to show you on the schematic, C7 is right here. So we're getting signal on this point here. The output of C7 comes down to L41. We lose the signal on the secondary side. So let's try some other bands here. Let's go to 7 mega, or let's go to 80 meter band. 3.8. .75 meter band's working. Let's try 7 megahertz. How about 7.194? Band's working. Try 10 megahertz. Try 14 megahertz. Working. 18 megahertz. 18 megahertz is working. Let's try 21. 15 meters is working. Let's try 24.5. Megahertz. 29 megahertz. Well, looks like all the bands are working. The unit is just deaf. Here's the schematic on a monitor. Makes it a little easier to see. Signal comes in through the antenna here, and this relay contact here is in the receive position. When this contact goes up, the transmit is connected to the antenna jack. So the receive signal comes down through here, out through this transverter socket on the back of the unit, and then there's a transverter switch here, and from there it goes up and over. And I'll switch to the next schematic here. This is in 2 parts. Comes down through the attenuator switch, and this actually works. As I toggle this switch, it changed the level a little bit, and then it goes on out of this switch. Where's this antenna? The signal comes in. This is test point 1. This is where I measured the signal was okay coming in. Then the signal comes down through some filtering, comes through these 2 inductors down into L41, which looks like it's for impedance matching here. It's a step-up transformer. I'm getting signal here at this point, and I'm losing the signal here. And I try to measure it at S12. There's no signal there either. So I'm not sure where I'm losing the signal. I can't get access to this board without removing it from the unit, which is kind of major surgery, so I'll have to do that. Hopefully the problem is just a solder joint. I checked the contact here, and there's no signal at the contact. So we'll move on from here. Well, I removed the RF board and I found the problem. L41, which comes out right here. And the problem is we've got an open winding. So I need to find another one of these somewhere. And I can show you L41, which is right here. So let's see which side is open. Well, I found what the problem is. L41, here's where the signal stops. The primary winding of this coil is open. Here's the coil, the transformer I should say. Nothing. Here's the secondary, here's the primary, open circuit. So I have to figure out where I'm going to get one of these. I might open it up and see if I can repair this. This might be tough. It does have a number on it. 3420 0405. I don't know who makes it. Maybe, well, I'll have to check the stuff here. So I think I will disassemble this and see if I can find out what happened. Either that or try to find a replacement of it. Anyway, that's what is stopping the input signal from getting into the device. I don't know if you can see this or not, but there's the wire hanging in the breeze of the primary. I don't think there's any way I could repair this. I'd have to find the other end of the wire. This stuff is finer than a human hair. I guess the only other alternative is to try to find another one. I removed the shell of it here. That's pretty amazing. I don't know why that wire broke, since it's contained inside of the shield. Unless a voltage spike got in there. I don't know how I got through the other circuitry. So anyway, that's going to put a end to this for now. There you can see the, get it in frame there. There you can see the wire hanging in the breeze. Here is the innards of that transformer. It's a step-up transformer. Very few turns. I measured the diameter and I get about 3/1000ths, which is, I think it's about 42 gauge wire. I don't have anything that small. I've got some coils here out of old hard drive motors that are 40 gauge, about 6/1000ths. So this is so small, it's really difficult. I'm going to look at it under the microscope here. We'll put it under here. Okay, here's the tweezers. Here's the tip of these needle nose tweezers. And you can see here, underneath, here's a broken wire. Right here. I'm not sure if I would be able to possibly, Well, if I could remove one turn of this. I don't know if that'd work or not. Bring it around. This stuff is finer than a human hair. And then I need to see which terminal it came off from. Here you can see just how small this is to work with. Now wait a minute there. Wait a second. Let's take a look at that. That doesn't look quite right here. That looks like the other end of the wire. Right here. If I can grab it. Alright, if I could connect this wire to this one. Easier said than done, huh? Yeah, this 42 gauge magnet wire is just way too small to work with. There it is. Alright, if I could connect this to this and make continuity there, right there. If I can solder these two wires together, I lost about a half a turn, but it just may work. There again, here's the core, or the shield outside of the. Here you can see where this fits inside of the shield, and then you've got the tunable, some type of ferrite material, I believe, right here that can be turned, and that's threaded. So maybe the futile attempt to solder those wires. I have to find a way to twist these wires together. Oh man, this is torture. You can see the lacquer, which I'll have to burn off. Let's get it back in focus here. As much as I can. Well, they're touching. I guess if I can solder those two ends together. Tip of my soldering iron, my smallest one, is probably half the size of that base. Well, we'll see what we can do. Well, none to lose. Here is Kester solder, 6040. It's 31 thousandths diameter. That would be this. And this is the soldering tip. I know you're laughing. Let's see if I can get it underneath here. Oh man. Are they touching? I don't think they're touching anymore. Easier said than done. Oh, let's see what we got here. Is it connected to the base? That is the question. Let's take a probe and see. Right here, one is on the base and the other one is... Huh. Well, now I need to get it. I need to get it so the... Need another tool. Let's see. Okay, I'll have to put the case back on. So here's a small screwdriver I have. Let's see if I can. Oops. Never say oops. I'll push this over if I can. Oh boy. Oh, I do not want to manipulate this very much. I want to see if that goes in the channel. Let's see. Check the continuity again. I've been manipulating this so much here. Get it back out a little bit. Get it in focus. Well, I think that's making continuity. But the question will be, Well, we've got continuity. Did I change it enough that it's going to affect the operation? Not shorted between the primary and secondary. Right. Now, can I get the case back on without destroying what I did? I need to get this back. Here's L41. I need to get the case back on and orient it in this direction. Here's the two shield solder points to solder the shield of the board. So we'll put the 3 in a row on the right and then orientate it that way. I think we broke the connection. Alright. Okay, here is desperation attempt number 3, 2, I don't know. Ooh, I think I need to cut my fingernails. What I've done is I've removed the windings from this core here. No windings. And I need to rewind the transformer, and I don't have any number 42, so what I'm going to do is I'm going to use this. This is a winding out of a computer hard drive, out of the motor, and I measured it, it's about 6 thousandths, which is, I believe, close to 40, number 40 wire gauge. So I'm going to rewind it. I counted the turns when I remove them. I'm going to rewind the primary and secondary using this wire, and if that doesn't work, I guess, well, we'll have to come up with a plan B. So I'm going to try that, and I'll get back when I'm either successful or failure. Anyway, stand by. Okay, I rewound the transformer, and I don't suggest you trying this. This was really painful. But anyway, we've got the 6-turn primary here and the 26-turn secondary here. Okay, to show you how small this thing is, here's the transformer versus a fingernail. And there's the form. Ooh, I might have to touch up that one. Well, I guess it's making contact. I got continuity. And of course, next, here's the shield, and the transformer will be placed inside the shield, and then hopefully it works. I don't know, this might be a long shot, but nothing to lose. I did find out, doing a little research, there's a guy that's selling reproductions of this, and I may have to resort to that, but the coil he's selling is actually cost more than the radio. So I'm going to give this a shot and check the performance of the radio and see how it works. I haven't tested the transmitter yet. I wanted to get the receiver working first, but next step will be to put this coil back together, or this transformer back together, and install the RF board and then give it a shot. So that will be the next step. Stand by. Okay, here's the transformer soldered back into the RF board right here with the orange cap on it. I'm measuring continuity, but I guess the proof will be in when I reinstall the RF board and give it the smoke test. Anyway, that's the next one. Stand by.
But just trying to get some people that have done photo, but nobody wants to do anything with me, so I guess I'm going to have to try and do something myself. So anyway, back over to you, Tim. K0SSD from W1AW.
Well, it appears to be working. I have it on a short wire laid outside the window, and it was that transformer that was bad. I rewound the transformer, put it back on the RF board, reinstalled the board, and it's working. So I guess I'm going to do an alignment on this. I don't know how many screwdrivers have been in this thing, so I guess I have a service manual, so I'll go through an alignment, but I haven't tested the transmitter yet. The guy I bought it from said the transmitter does work, but we'll see. But anyway, another Hamfest special. I like these old rigs. I like the old hybrids, the Kenwoods and the Yaesus. So I think I'll wrap this video up now, and I'll have to get this on the air. I don't have any antennas for HF right now hooked up, so I'll have to wait and see. I'm anxious to get my tower back up so I can try some of these old rigs out. I got quite a few of them, 520s and 820s, now 830, so they always seem to follow me home from Hamfest. Anyway, that's it for this one. So thanks for watching, and see you next time. Bye for now.